Recording is on.
Okay.
I just couldn't resist, Eric. Sorry.
Yeah, I hear you. Okay, good evening, everybody. Thanks for joining us in. And like I was mentioned earlier, we should be outside, but then the heat is such that we're probably in the best spot in the house is in the basement. So anyway, thanks for joining us. I see that a couple of the regulars are missing, but that's their problem, I guess. Okay. Tonight I have a little short on what happened with a SOAREX field day to coin it a little bit. So we'll do that. And then Kevin's going to have a little talk about some nasty software issues that can happen. So that should be interesting. There's been quite a few interesting things that have happened over the years about miscalculation of software. So with that, let's get started here. You guys can see that?
Yes.
Okay. Okay, so I guess everybody's aware of the acronym there. This one stands for this time, one weekend at Eric's farm. So SOAREX field day, et cetera, and et cetera means, well, of course, when we all get together, us homebrew guys, we have to talk about our projects and things like that. So this is what we've done. Okay, so on the left there, we're getting set up for some antennas, and Eric is getting ready with his slingshot.
Okay, let's see it go over now. Yeah, it went over.
And I hope nobody was paying that close attention to that video. There's Ken on the right, and you can just see Eric in the background in the other field putting the antenna up. Full disclosure, it was a reenactment on the slingshot, but I believe Eric got it over the first crack at it, I think, which was way better than what we did last year. Okay, there's we're set up, ready to go. Very nice location in there. What's interesting, even though it's all open, the bugs generally aren't too much of a problem, so that works out well. Good shelter, nice little breeze blowing through there to keep things nice and cool. And there they are at the bottom right there. They swapped the operating positions. And the rain came down big time. And actually, I'll go back to the slide there. If you notice behind us, you can kind of see where Ken's getting a little bit wet on his shirt there. The rain just started to blow in a little bit in the back there, and we thought we were going to have to close up a little bit there, do something different. But then it didn't last long. I don't know, 5 minutes maybe, if that. And then it was gone. But boy, did it bucket down to start off with. It's not a bad ground plane there, right?
I think the only thing that got a little bit waterlogged was a few bins that we had out that I had to dry out the next morning. But yeah, otherwise no equipment was harmed in the production.
That's right. Just another view. The rain was over, and you can see the antenna feed point there. And that was about as best as the skies got that day. So evening rolled around, and Hassan showed up in the evening, and you can see from the picture there on the left there, he was all raring to go. It looks like Eric is a bit fading there. He stuffed himself silly with the pizza, so I guess he's feeling the pain from that. On the right, there we are, still operating. A poor attempt at my selfie, I guess.
If I can add some commentary, though, I was sitting beside Hassan, and at one point he closed his eyelids and he started snoring. So, you know.
Hey.
Just saying.
Hey.
Yeah, I can do that.
It's covered. Okay, Eric, quit jumping the gun here. Oh, and in that note there, you can just see, I'll see my mouse shows it off there. Anybody know what that is? Guys who went to 4 days in May should know what that is. Belongs to Eric. That's far ahead.
The theremin, is it?
That's far. Oh, geez, don't even. Hey, you know what? He didn't bring it up. I guess maybe Dave stole it. Anyway, no, that's the box for the SBIDX. And as Eric alluded to, there he was. He fell asleep. And Eric over on the right there, I think he's starting to get set up to work on the SPX, if not the Raspberry Pi clock, which you can see is running. Anyway, so there's Hassan gone to sleep, snoring away. And then he's awake again. Wow. And now he's back. And now he's gone back asleep again. He did that about 3 or 4 times before he finally packed it off and went to bed. Anyway, it was a lot of fun. So, like I was mentioning, we just didn't do radio stuff there. We brought up stuff, like I say, on the left there. Eric is getting ready to do the SPX and his Raspberry Pi clock he configured earlier in the day. The bottom right for me is the Phoenix. I brought that up to configure the, well, you can see the Park SIGGEN there in the corner of the board. And I was going to configure that up to control the radio, because up until now, I just used the signal generator. And to that point, because the signal generator for the VFO and BFO worked, and the radio worked well, at least the receiver portion, I thought, just in case, I'll bring it up with me so that at least I know it works and I can start from there. Unfortunately, it went deaf. I could hardly hear any of the stations. If you can hardly hear a station on field day, something's really wrong. So I switched antennas in case that was it. And it was basically the same thing, slight improvement, but nowhere near as much. So I'm not too sure what I broke. Hopefully nothing worse than maybe there's a crack in a trace or something happened. I'm not sure, but it was working in the shack before I packed it away, and it wasn't working when I got to Eric. So who knows what's happening there. And then, of course, there's he who has to shop, had to shop, and Al Wolfie brought up a trunk full of goodies for sale, and well, you can see the result of that. So Eric is warming up yet again for LobsterCon. Okay.
Can you go back one slide there, Peter? One
This
more.
one?
Yeah.
What about it?
Hang on, just Dave.
Tell him he's got the ports reversed. He's got
Just tell him.
the SIGGEN, because if I turn the mic on, you can get
Okay.
feedback.
Dave says you got the ports reversed.
What do you mean I got the ports reversed?
On the SIGGEN.
On the SIGGEN, you got it backwards.
No, I'm not using the SIGGEN right there at the moment. Oh, what do you mean I got? No, I'm not backwards.
No.
Besides, how could you tell? You can't read the frequency display anyways.
Because I would think port 1 is for the goes in.
Do you hear that?
Port 2's
No, I can't hear him.
He says port 1's input, port 2 is out.
mute.
No, I'm using one port of the SIGGEN for a VFO, and the other port is for the BFO.
Hey Pete, it's the like normally when I do the Park SIGGEN itself, port 1 goes into the RF, the first port on the Phoenix, which you've got in your SIGGEN. You've got port B, the second port plugged into, then you've got port A plugged into the BFO port.
Yeah, but as long as you got your
SIGGEN, it's
frequencies
reversed.
correct on the SIGGEN, that
The
would
Park
matter.
SIGGEN, it's reversed.
Oh, okay, I see what you're saying. So pay attention to the for that on the SIGGEN. Okay.
Do you understand?
Yeah, when I switch over to the Park SIGGEN for the controller, I gotta watch
Do
which
you have
one.
your volume? I can't hear.
My volume's off.
Oh yeah, no, I got my.
Oh, you're asking if I could test it.
Have you guys got your problems figured out? Anyway, I think I understand what you're saying on the Park SIGGEN, which is what we're using for the controller. Port 1 is for the VFO? Will we lose those guys?
One of us has to mute, one of us doesn't.
Yeah.
So Dave, port 1 on the SIGGEN, on the Park SIGGEN is a VFO?
Your Dave
Yeah,
says
like we have Peter. We've got two computers going here, and we have to make sure we mute each other's PC. Yeah, on the Park SIGGEN, SI 5357 port. What is it? 0, I guess. The first port. That's where goes to the RF. And the port C or port 3 or port 2, or whatever the last port is, that goes to the BFO.
Yeah.
On your SIGGEN right there, you've got the ports reversed. So your SIGGEN, you're putting out the RF on port 2 of your SIGGEN, and on port 1, you're putting out the BFO frequency.
Yeah, but that's okay. It doesn't matter.
Yeah, that's fine.
Yeah.
Not a problem. It just, you got to make sure you plug it in the right way around on the SIGGEN.
I got you on that one. Yeah, that's a good point there, Dave. But unfortunately,
Are we looking at this?
Pardon?
Are we looking at the same slide here? I can't see any ports on the SIGGEN.
Well, it's very small. Dave is referring to, see these ports here on my SIGGEN, the port 1 and port 2?
Over there. Got it. Okay, fine. Yep.
See, I've got port 1 going over to the BFO on this side here. Dave is just reminding me,
All
port
right.
1 on the Park SIGGEN does not go to the BFO, it goes to the VFO.
Okay.
So, okay, well, thank you, Dave. If that's my biggest problem on the next up, I'm doing all right. Okay. Okay, so like I said, it's always good to these little get-togethers we get going there. We do a little bit of radio operating, a lot of home brewing kind of topics and stuff like that. So maybe we'll get another one organized for later this year or into the fall or something like that. Maybe like we had, 1 week at Eric's Cottage maybe.
You didn't mention the biggest problem that we had with the antennas, trying to get, they're all out of whack. Couldn't get them tuned up properly on like either my 80-meter inverted V or the NFED.
The SWR was really, really bad. So,
yeah. However, that being said, we did make 131 contacts by the end of the 24-hour period, so I thought that was fairly impressive.
If you had a good antenna, we probably would have made 500. So, anyway, it's funny. We thought, well, let's figure out this antenna before. Let's do some measurements before it gets dark. So we did, and we discovered. I think the NFED was about 8 or 9 to 1, 10 to 1, or something like that when we started.
Yeah,
and I think we got
about 5. I think
maybe 5.
Anyway, 5 or 5.5.
The way you were trimming back wasn't the good way to go, but that's a discussion for another day.
As you said, the tuner was getting very warm, but anyway.
I kept questioning, why are you guys using an outboard tuner when you got a built-in antenna tuner in the 7300? Made no sense.
Point.
Well, now I know why, because
match
the
higher.
Tuner couldn't handle the SWR.
Right. The 7300 can craps out at about 3 to 1, whereas I think his LDG goes higher. So, kind of save the bacon, I would say that day.
Anyway,
so Peter, the fact that they were using an external tuner to tune, which tunes a much broader range, means those antennas were not tuned.
They were terrible.
Detuned, and they weren't even on the right resonant frequency. That's why you needed a much wider tuner to tune it back.
Anyway, we're not ever going back to Eric's place until he gets his antennas tuned. That's for sure. Okay. Any other comments before we move on? All right. Well, Kevin, are you ready to have a chat?
Yeah, sure. Actually, okay. So before I start, I just want to preface a couple things here. One is I've always had a kind of an interest in this stuff. I don't know why, I just do. Part of my job when I was at Hydronuclear was on a team where we investigate incidents and try and find out what happened and why it happened. And usually, as like most things, it's human factors, right? It's not necessarily a machine failure or whatever. It's quite often a human failure or a human misunderstanding, whatever. This also applies to software. And Dave, just forewarning you, is Dave still here? Yeah, okay. Dave, the reference to drones in my thing was there before your presentation last night, which I happened to be the first view on that. So I did watch it, and I'm not trying to poke fun at it or anything. You had some valid points, and I think a lot of, unfortunately, the only drones I've ever seen are ones that are acting irresponsibly. But anyway, but that's to the point. There are thousands of people out there that operate them responsibly. With the exception of you at Eric's Cottage, you were doing it responsibly, but all the other incidents I've seen are quite not good. Anyway, so that said, let me get things started here. It's short, but this is more to make you think about why, and it's not that we're writing software that's critical for things or for people to be safe, but we do write software. That's part of what we do. And you never know where it's going to end up or what it's going to do. And you probably can't imagine how it could affect something. And this is to kind of, get people thinking about how the most mundane things can affect you in ways you can't imagine. So anyway, let's see, share screen. Oh, there we go. Window and okay, so let's start. So anyway, as always, I like to, give a plug to XKCD. This is not how you, do a help manual, right? Planes crashing. Oh, check the manual, check the online reference. Yeah. Anyway, so software bugs and things that are not necessarily good for you. So why do we care about this? Well, you just reboot things, right? I mean, you get a blue screen of death, the YouTube stops working or whatever, you just reboot. I call it the Bill Gates fix because, as Dave has experienced lately, Windows is not always the most reliable way to use a computer. So anyway, but it's not okay if you're, driving a vehicle or flying in an aircraft, or you live near a major processing plant or anything like that uses software and equipment to control processes that are or could be dangerous, or and there's a lot of devices and machines that rely on software for their operation and control and safety. And that includes even like a lot of machinery now in factories, which is part of my day job, where programming these safety PLCs that are required to meet certain, stipulations as to how they're designed, how they're programmed, and they're designed to fail safe in any, any unforeseen situation so that nobody gets hurt. Anyway, so I've got 4 incidents here that, just want to go over. So anyway, the first one, and this was actually while I was at Bruce A, back in January 1990, during a refueling procedure. And this here thing, this with all these little things sticking out, that's the face of the reactor. This is a fueling machine, the big yellow thing there. Anyway, it goes up on an XY gantry, and it along with one on the other side of this, on the back side, it puts new fuel in and takes old fuel out. So anyway, it's doing this, it's hooked up, these things run at 1500 PSI. Give or take, and there's brakes holding this in place. Anyway, during the procedure, all 4 brakes that were supposed to hold it in place, and I'll bet there's only probably 1 or 2 needed. Anyway, all 4 of them let go, and it kind of dropped, and it broke the connection, and there was like heavy water everywhere, and it's and it's hot, and anyway. So what happened? Well, back in 1986, so 4 years before this, somebody was reprogramming one of the control computers, and they entered a single wrong number. And which you think, oh, well, you'd catch that right away. No, it required a bunch of very specific conditions until that code branch got executed and resulted in the incident. So anyway, and I have references here for anything that, if people want to see them, I can post them on an email in the group later if you want. So that's one incident. nobody got hurt, you know, bit of a mess to clean up, a little bit of radioactivity, nothing was released, nothing serious anyway. They have their license lets them release something like 1 million curies of radiation a year, just so you know. It's not, so they are allowed to release some. Anyway, another one in June 1996. So the first Ariane 5 rocket takes off. 40 seconds later, starts veering off course and does a self-destruct because it realizes that it's not in control anymore. And it's like, okay, well, this thing was like expensive, 10 years, $7 billion to develop this new version of the Ariane 5. Well, the problem boiled down to be a software error in the inertial reference system. So they were using, and they were using a 64-bit processor, I believe, but the library was using 16-bit signed integer values in one of the libraries. So a 64-bit floating point goes up to 2 to the 53rd power. A 16-bit signed integer only goes to 32,768. So if you try to copy this number into this number, it doesn't fit. And the result is that the rocket didn't believe it was going in the right way. And what's even worse is that it didn't even need to do this. This routine that was calculating this was left over from the Ariane 4. And they just left it in there because, you know, just people program. And Dave, you probably realize this too, is like, programmers don't like to change software. If something's working, don't mess with it because you don't know what the side effects are. And this is also one of the problems in software. Because if you don't understand the whole thing and understand it to a very deep level, you are very cautious about making changes. So, and by the way, just I can't see anything. So if anybody has any questions or whatever, you have to speak up. Next one. And this is the third one. So February 1991, a Patriot missile battery in Saudi Arabia. There's a Scud missile coming in. I don't know, some people may remember this or not. Anyway, it actually hit the soldiers' barracks, and with the result of, a bunch of people dying and a lot more people injured. And the problem is that there's this clock inside that itself, sort of a self-accumulating clock, and it uses that in a targeting calculation. And this thing had been running about 100 hours, so what's that, 4 days, give or take, and it had accumulated an error in the clock of only 1/3 of a second. Well, this missile travels about 1 mile per second, so at 1/3 of a second, it's 1/3 of a mile out, so it was looking in the wrong place. Why did it do that? Well, it turned out that the range gate calculations on the Patriot missile battery uses 24-bit floating point, and every 1/10 of a second it adds 0.1 to the second total, or the second counter. So it's counting seconds in 0.1 of a second increments. However, in 24-bit binary, you end up with a 9.5 nanosecond error every time you do that, because it can't actually represent 0.1 as 0.1. It's got this small error. So after you do this for 100 hours, you end up with 1/3 of a second error. And so what's even worse is that, not worse, but maybe what you might want to ask is, the Patriot missile system apparently was intended to be a battlefield unit, and therefore to be moved frequently, like every day, literally. And so when you reboot this, the problem goes away because you start from zero, right? You start with 0 error. And this use case was they basically parked it by the barracks and turned it on and left it on. So, they were using it in a way that it was never designed to be used. So is it really a bug? I don't know. I mean, and this is also part of the thinking, is when you're doing something, what if somebody uses it in a way that's not intended, right? So, and then probably one of the most famous ones, and it's Canadian. So, don't like to, we need to realize that everybody makes mistakes. And this was part of the AECL organization. And so they had this thing called the Therac 25, and it was a radiation machine that used for treating cancerous tumors and other things, I imagine. And it can generate either an electron beam or X-rays. And that was part of the setup and the protocol for treatments that they would enter for each of the machines. So previous generations of the machine used hardware safety interlocking. So regardless of what was done, it theoretically couldn't get into an incorrect configuration. However, the Therac 25 decided that they were going to use software for everything. And this was before the days of safety PLCs and all this kind of stuff, where it's a lot more standardized now. So 6 people got serious radiation overdoses, and I believe three of them died, several anyway, from 85 to 87. And the overdoses were significant. It wasn't like a little bit, it was like 100 times in some of the cases. So there was some significant health issues after that. And why this happened? Well, AECL at the time, there was like really almost no software specifications or testing requirements. They used a custom real-time operating system. One person designed it, nobody reviewed it. And they had this, this infallible belief that it's good and nothing could fail. The operators were used to frequent error messages. That's called normalization of deviation. So if you're used to a machine that always kicks out errors or gives you blue screens of death or whatever, you get used to it. And after a while, it's like, well, that's just the way it is. And you don't think anything of it. And it ended up, I think it was a physicist actually, I think in Texas, that worked for one of the hospitals, determined that a software race in the user interface allowed it a dangerous setup condition. Basically, it allowed they set up to generate the X-rays. They cranked up the power on the electron beam to like many, many times what they would normally use for an electron beam therapy. And they ran it through a tungsten target to create the X-rays. But the error was that the tungsten target wasn't in place. So they basically got hit with this really, really strong beam of electrons. And in some of the cases, and that was one of the major errors. The Therac 20, which was the previous version, it had the same bugs. So they copied the bugs, but the hardware interlocks prevented any serious faults. At least the ones prevented or experienced by the Therac 25. So hardware safety interlocks, saved the day earlier. They just didn't realize it because they had, and one of the things was they had almost no logging capability. They didn't know what was going on. Very poor software design and diagnostics. They are better now. I can say this for a fact because I had or at least a personal experience. A friend of mine that actually went to work for AECL back in the mid 90s. One of his jobs was examining the microcode in a microprocessor. So they were looking at the very, very low level code inside a microprocessor. And they had found 3 errors in the halt instruction alone. So there was 3 issues in the halt instruction for the microprocessor. So they are very, very wary of software and issues and stuff like that now. Obviously it wasn't the case back then. So, and this is second last slide, but just some things to think about. And so, these are things that may or may not be important, but so one is, you can start the washing machine. You're going to leave the house. What if the fill sensor fails and the machine doesn't know it? Or a software routine that controls the fill valve has an untested code path and the fill valve stays open. Okay, so you flood your basement, or at least you get a lot of water on the floor and hopefully there's a drain nearby. Or the electric vehicle you're driving with auto cruise. And I say auto cruise because autopilot just doesn't exist yet, no matter what some marketing people would like to say. And the front facing camera sensor becomes completely saturated, but the saturation is due to a big white semi trailer in front of the vehicle and not just blue sky. So the vehicle keeps going because it thinks it's just blue sky and it doesn't slow down. Okay, Dave, close your ears now. But anyway, or that software controlled drone hovering above a crowded venue taking video. It decides it needs to land because there's some error, software or otherwise. Does it turn off the motors and crash, or does it try to descend with the prop spinning at 8,000 RPM and go into the crowd? Or the flight control algorithm. I mean, I was watching some of those videos that you referred to, Dave, about the building diving and stuff like that. And it's like, you know, those things are incredibly responsive, but there's also some things, you know, where something weird happens. Now, is it operator error? Is it software? Nobody really knows, because I'm sure this software, while sort of tested, is not certified. And, you know, but anyway, maybe it is. I suspect it's not. Or the ECU on a vehicle, I'm talking internal combustion engine vehicle, has the following issues: buffer overflow, invalid pointer references, task race conditions. These are all various software things that, if you write software, are bad. So, and to reset an unintended vehicle acceleration from a stuck throttle condition can require the removal of pressure on the brake to reset the task control. And then you have to reapply the brake to stop. The sad part is that 3 of these 4 things are documented as having taken place. Now, like drone 1 wasn't exactly like that, but a drone did fall into the crowd in Quebec City over a 5K run. It was documented by another drone that happened to catch it on film or on video. The washing machine, I'm sure it's happened. I just don't have any documents for it. So anyway, just, you know, there's some thought out there that, and I actually have run into this at work with some newer employees that, you know, moving fast, breaking things, you know, well, they just write software and hope it works out. And that's not the way you do this, not when it's critical software. And design and specifications along with testing, because software is all about testing, is the way to get better software. Anyway, so that's it. That's my rant. And let me stop sharing. There. Okay.
All right, we thank you very much for that, Kevin. It was an interesting rant. So let's keep ranting away. Live from QC has a question.
I thought there might be one there. You're muted, Dave.
I'm trying to take my hand down. Is my
Oh,
hand
okay.
down? Yeah, okay. Yeah, no, Kevin, you're bang on about the drone. You're absolutely bang on, because, and I've got a couple of things to say, but I'm going to say one, and then I'll come back. I'll give some other people a chance to jump in and speak. But as far as the drone thing goes, I think, you know, there's a whole bunch of posts in the drone community about this remote ID in the States, and they're saying, well, it's because of Amazon and Google buying politicians so they can control the airspace, because they want to get modelers out of the low airspace, so Google and Amazon could start doing drone deliveries. Okay, I think, and you hit the nail right on the head, the reason why Transport Canada and the FAA has implemented such draconian regulations around drone is because they're scared shitless. Is because, okay, in a commercial aircraft, it's predicated on failure. If something fails, even a small Cessna, you got dual mags, you got dual plugs, you've got things to, in case something fails, you've got a better chance of recovering from it, right? In the case of a drone, you're absolutely right. Something fails, there's no recovery whatsoever. So Amazon that's flying a drone over somebody's pool and a motor decides to quit, or the battery goes dead, or the battery's weak and it can't return home, what does it do? What's the failure mode? And I think that's why they're putting such draconian regulations, is that they want to put this genie back in the bottle to say, we have to control this. We have to scrutinize these drones from doing things commercially in a manner where if it fails, it could jeopardize public safety. So no, you're bang on, my friend.
Okay. No, So anyway, that's my thought. What else? Oh, Drew. Sorry, Drew's hand is up.
Yeah, hi. That was great, Kevin. It was really very, very insightful. I don't know if you will recall, but around 90 or 91, maybe a little later, the professional engineers in Ontario made a move to license software engineers. And you can imagine the level of pushback that happened because there are, of course, a lot of non-engineers who are writing software, but it was based on what you just described. The realization that software was a great deal more potentially lethal than anyone had ever imagined when they had their Apple II sitting on their desk. And what you have underscored, I don't think is getting caught onto by a lot of people who are surrounding themselves with the Internet of Things. I, for one, am not a big fan of the newer fangled appliances for that very reason. I have no idea what they're doing. Anyway, it was very, very good and telling story. I like that.
Thanks. Frank?
Yeah. Your presentation was very good, and it brought back something that I experienced many, many years ago. And I was working on the hardware crew to support the first UNIVAC computer, which was installed at London Life Insurance Company. And we got a complaint from the London Life that our computer made an error, and obviously it was hardware. So we went to work to find out why. And what happened was a long-term policy holder who usually paid monthly, all of a sudden got a past due notice. Well, make a long story short, and believe me, it took a while, that in the software, they had a routine in there that took care of the number of months that he has paid. And if he could pay ahead. So if he paid ahead, 7 to 8 months, then that was fine. And it went into a register, which was only 16 is the, because, storage was right there. The whole thing ran on 2K of memory. So what happened was this fellow went out of town, out of the country for 2 years, but he paid up ahead. But he didn't pay an annual amount up ahead. He paid 24 monthly payments. Well, everything ran on beautifully for over a year. Then all of a sudden, it got to 17 and it popped out a past due notice. And they said they swore it was the hardware because that's all they knew. So we weren't software people, but we had to dig in there and find what the problem was. And sure enough, that was the problem, was a programming problem.
And then software guys, Frank.
Was it programming or was it misused? It wasn't the right use case. They let him pay 24 months and they should have only let him pay 16 ahead.
No,
you could argue that.
It was a combination.
It's always a combination, but it's like the last incident, and I didn't want to name names in some of these more. You'll notice that all of these were like 30 years old. That's deliberate because this is on YouTube. But that last incident there, I actually had that vehicle when it talks about all the software issues. And they went around and said, bring your vehicle in. We're going to cut the pedal down because the mat was, blocking your accelerator pedal, which I knew was BS at the time. And anyway, after the civil lawsuits and the government and the NASA investigations and separate investigations from other people that investigated the software, all of a sudden there was a recall for a firmware update. So you had to bring the car in for a firmware update, and it was very important that you brought it in right away. So there you go. Anyway. Yep. Go ahead, Mr. Live from QC.
Yeah, so the other, okay, my hand's down. Yeah, the other thing I wanted to mention, Kevin, it's, yeah, by the way, that was an excellent talk. But the other thing, you reminded me of a presentation I was at I think we talked about Sector, the Toronto Security Forum that's held every fall. This is prior to COVID. This was a few years before COVID. I attended a presentation, and there was an Italian professor talking about robots used in assembly line, assembly lines. You know, they have the robots come out and do welds and they tighten bolts. And he was studying security in these robots. And so he was saying that a lot of these robots, what happens when they initiate themselves, the robot arm is going to sweep around 360 degrees and come back to the home position, just like a CNC machine or your printer, or not your printer, your
like a homing cycle.
3D printer, you know, yeah. So it comes around and it goes to the home position. So when there's a technician working on the robot, there's an interlock switch. He's supposed to go in and remove the switch, and that disables the robot, the actual mechanics from working. So this guy, this professor was talking, he said he found several robots where the interconnection, even though it was removed, the robot would reset based on a wake on LAN. You know what wake on LAN is? If it gets a packet addressed to that Ethernet address, it wakes up. And so what'll happen, the robot will swing around. And if that technician's there working on it, that arm's going to swing around, hit him, and kill him.
Just as a comment to that, and just to make everybody hopefully feel a little bit better, if you don't know the state of what safety stuff is out there these days, in factories now, there's what they call safety PLCs. And what they do with those is it's a very limited set of instructions, and you have two processors generally. One processor does the Boolean logic that you put in, and then what the compiler does is it inverts the Boolean logic so that it takes, you know, an AND instruction and converts it into the Boolean inverse equivalent, and that's executed on the other processor, and they both have to agree for something to happen. And so that's what they're doing now in safety PLCs. So you have a very limited set of instructions, nothing fancy, but it lets you program safely. And also to your point, Dave, about the drives, like, you know, robot arms moving and stuff. Now they have what's called a safe torque off on almost every drive. And what it actually does is it interrupts the gate signals to the power transistors. So even if the power transistors short out, that won't turn an electric motor. It can be live, it can have power on it, but it will not rotate because it can't create a rotating magnetic field. And so that's what almost every drive now you buy has that capability. So that's making things a lot more safe. And I'm sure, I don't know that for a fact, but I'm sure this is starting to spread into hopefully things like scooters and e-bikes and, you know, electric cars. Well, I'm sure it's in electric cars. I'm almost sure that the inverters in there have that kind of safe capability, but anyway, who knows? And that electric vehicle one with the semi truck, the guy died in that. That was in Florida, I believe.
Yeah, Kevin, I remember when for a couple of years I worked for SPAR Aerospace as a network engineer there, and I worked alongside the guys who were writing code for the shoulder for the ISS. This was way back in the early
arm, right?
Yeah, for the arm. It started out being a shoulder, and then it became a arm. So anyway, but NASA, when you write code, you're a subcontractor to NASA. NASA has got very strict rules around every piece of code, every subroutine you write has to be tested.
I read some of that stuff. Yeah, it's mind-boggling.
Yeah, and then you have to test it. It's got to be documented, dated. This is how you tested it, and that version of that subroutine or that library, that's what has to be validated to be running in production code. And they have to write these extensive test scripts to test every conceivable use case, both positive and negative. use case.
And that's, you know, and to Drew's point earlier about, you know, people writing software, it's like, whether you're an engineer or not, you know, you can write good or bad software. And part of the problem is that this goes back to, Veritasium has an awesome video on incompleteness. And part of that, it talks about the Turing halting problem. And this is the root cause of a lot of this software stuff. But to your point about writing good software, back in the 90s, there was this group, I think they were called the Capability Maturity Model. It was out of Carnegie Mellon University, and they rated organizations on how well they could write software on a scale of 1 to 5. 1 being like AECL was back with VERIC 25. It was like no procedures, no testing, almost nothing, right? 5 was you could almost predict the number of bugs you were going to find. And at that time, and I'd have to dig the article up, but at that time, there was only 2 organizations in the world that met the 5. One was a Motorola group programming microcode in Bangalore, India. The other one was the group that wrote the software for the space shuttle. That was it. Nobody else met that. IBM, I think, was a 2. Raytheon was doing, you know, defense contracting. I think they were a 1. So it was like, at the time, it was like, so it's come a long way, but, you know, obviously we still aren't very good at it. Sorry, go ahead, Hassan.
Yeah, I used to work at Motorola at the time, and I heard stories about this Bangalore group. Apparently, they were level 5, and yeah, but I think their processes were so onerous that everybody else found it hard to work with them.
What does that tell you about the complexity of writing good software?
Well, it's that's the funny part. So writing the code was only 10% of the process.
Right. Exactly.
So most of the time was spent planning, writing test cases. Yeah.
I tell my guys this. It's like the last thing you do is sit down and open up the Alan Bradley program to write code. There's so much other stuff you have to do before you actually write one line of code. Anyway, sorry, go ahead, Dave.
Yeah, it's kind of interesting you mentioned the CMM model. I use that all the time to rate companies around their security maturity, because you could use the exact same system to rate your security, whereas the 4 and 5 is feedback. You're measuring security, you're actually measuring it, and you're coming back with a numerical value. And the majority of hospitals in Ontario, guess where they stand?
I don't want to know.
Yeah, it's very low. It's usually
I'll bet it's not a 3. I'll bet it's not above a 3.
No, it's usually 0 or 1. It's like because 0 is like ad hoc. You're not doing much. 1 is where you're just beginning. You're just starting to get policies. You're starting to get organized. Most of them were like a 1.
Yeah. Peter.
Going back to your first slide, you wouldn't have to know what those conditions were that set the brakes off, do you?
No, I don't. I'm sure knowing nuclear, it probably needed 1 or 2 brakes to hold it in place, probably 2, 1 on each axis. And then it had it had backups, like 100% redundant backups. So probably an extra 1 on each axis. And, you know, obviously they're never supposed to all release unless there's a deliberate move, and certainly not when you're hooked up to a high pressure fuel tube.
No.
That is the one time you do not want to move. Anyway, okay. Well, if there's no more questions, then I'm done. Something to think about the next time you program an Arduino.
I wasn't going to bring it up, Kevin, but
yeah, I know. I'm trying to do a good job, so it takes a long time.
I understand that, and that's why I didn't say anything.
It's just not been, you know, it needs to be high enough on the priority list.
That's right.
It's kind of interesting. Eric was asking me, he said, "Oh, what's that race thing you were talking about?" And I said, "Remember, I had one of those when I wrote the SNA software. There was a race condition in the way the rotary encoder was working, and it would skip steps.
Oh, that's a little more down there.
Yeah, and even, you know, everybody thinks it's so simple, but it's even something simple as, so one of the things in computer language is atomic operations, right? So if you've got a 16-bit processor and you're writing a 16-bit word, you can do that in one operation. But if you've got an Arduino, which is 8 bits, all right? But if you want to write a 16-bit word, well, it has to grab 8 bits and move it to a memory location, and then it has to grab another 8 bits and move it to another memory location to get the 16 bits. Well, what happens in between those two? What if you've got like a multi-threaded application? So like in every computer now, almost, it's got, you know, things interrupting other things. And what if something happens in the middle that it goes to look at that memory location where only half the word is written, the first 8 bits? The second 8 bits haven't been written yet.
Yeah.
This is the kind of thing that, you know, this is at the compiler level. Like, it's like just, you have to be incredibly detail oriented and obtuse to just keep track of all this stuff. Very complicated. No wonder we don't do software well. Anyway, that's my rant.
Okay.
On to more pleasant things.
Okay, well, thanks for that, Kevin. They're most interesting. Okay, good. All right. Oh, I see. Oh, very nice. Who's doing all that stuff? Is that you, Dave? Hey, oh, that's you. Okay. Okay. Well, I guess we can move on to. Does anybody else? Anybody want to bring up any kind of topic on something or questions about anything before we move on? No. Okay. All right. Well, then let's do our usual roundtable on our mixer, and I guess I'll start off. The last couple of weeks, I guess, just scrounging some more parts, going through some part bins that's been made available locally here, and trying to find a part to see, what project can I build out of that? And I highlighted a little bit of receiver problems with my Phoenix project, so that's just about ready to dig into that one now. The active probe that's been in my mind is still in my mind. It's just a thought exercise at the moment. I've started to look into audio active filters, and I started to do a KiCad layout for a filter I have in mind, doing something there. As if I didn't have enough to do already, I got to start something else when I haven't even finished some of the stuff. Anyway, so that's what I've been working. Oh, speaking of active filters, I just read yesterday, I think it was, that Don Lancaster of the cookbook fame passed away. Okay, that's all that's on my bench, and I guess I'll go. I know, Frank, you got your time sensitive a little bit there, so I'll go over to you, Frank.
Okay, Peter, thank you very much. Because of my physical condition, etc., my bench is pretty clear. However, in rebuilding the HW9, not rebuilding, but finishing HW9, there was a need to replace a coil. And after a long search, I finally found a supplier for this coil. And so I ordered it, only to back in May, and the forecasted back order was to be delivered in, that's it there.
Recording is on.
There's the coil. And you can see that it comes without a case. There's all the ones on the kit have aluminum cases on them. This fits perfectly. It's the right value. Everything's fine. Now I've got to go back in the internet and hunt for a case, which is similar to the old time IF cans that we had, which you put the screw in the top of them to adjust them. There's a ferrite slug in there that goes up and down. So I'm going to be spending the couple of weeks now with the internet trying to find a case. So that's about where I am. And back to you then, Peter.
Okay, thanks, Frank. Michael.
Not much to say, really. I've been thinking about the fact that at some point I agreed to, foolishly perhaps, I agreed to do a presentation on the tiny SA. So I've been thinking about that, doing a bit of reading and trying to understand how it works in terms of resolution bandwidth and those kinds of things. So I'm getting there, but eventually I'm going to do some kind of presentation on the tiny SA and how it compares perhaps with the Siglent 3072. And to that end, I was looking at a YouTube thing today or yesterday about one of the guys, I forget what experimenters guy, and he was talking about building little matching devices to to allow you to put one signal in from a 50 ohm load, a 50 ohm source, and it's basically a pad, building a pad basically. So I'm going to experiment with that, and he explains how to do it. Very simple. It appears to be very simple. It's just a bunch of resistors, and so I'm going to try that anyway and learn how to do that. So that's about it, really. Nothing else.
Okay.
Back to you.
All right. Thanks, Michael. I look forward to hearing your results of the comparison between the two devices. Let's see. With the droppings in and out of here, it's all shuffled all around here. Okay, Al, how are you doing tonight?
Am I on?
Yeah, you're on.
Oh, geez, I'm not muted. Well, it's summertime. I'm not doing too much, but I do have a hard time finishing things. And then I think I must have attention deficit, because next thing you know, I go down a rabbit hole and find something else. So I think on our last mixer was your thought of an active probe caught my attention. And I picked up a couple of reprint books from the GQRP club. There's a couple of volumes of projects for the radio amateur. I think the author is Drew Diamond or something like that out of Australia. So I picked that up, and lo and behold, there was an RF probe. Don't have one. Decided I needed one. So the last week I've been playing with that. So I just finished it yesterday, but you can see it's a nice little probe built into a magic marker from Dollarama.
Ah.
So it works out fairly well. And then there was a matching, is that going to focus? There we go.
Yep.
Yeah, a matching dummy load. It's 4 watts continuous. You could probably put QRP 10 in for maybe half a minute or something like that. Just a couple of resistors in there. Actually made that out of epoxy printed circuit board. Just cut that, soldered it together, and it worked out rather well. So, and the probe there is actually a meter probe, so I can actually stick the two together, just like so.
Oh yeah.
And I tried it last night. It works. Compared it to my scope, and on a small QRP transmitter I had, and I was fairly close, within 5 or 10% of the calculated power. So, yeah, a handy little thing for checking that you maybe in the field that a QRP transceiver is putting power out. You know, it's probably better for relative voltage measurements and absolute measurements, but it gives you an idea what the power is. I guess the probe would work with a suitable higher power load as well if you want to do a higher power radio. So anyhow, it was a bit of a rabbit hole. I liked it. I decided, I need one of those, and that's what I came up with. So yeah, fairly happy so far. I'm going to do a series of calibrations and see whether it changes with frequency. Right now, the only signal source I tested it with was a 2 watt what was it, a 40-meter transmitter. So, but so far so good. Apart from that, it's summertime, so I don't think I'll be doing anything over the next few weeks. But we'll see. If I get ambitious, I might do something else.
Okay, that sounds great, Al. I'm glad the active probe chat got you thinking and drove you down another little hole there. I'm beginning to think I was getting lonely in these holes, and I wanted to see if I can bring somebody to join me in them. Okay, thanks for that, Al. Drew, what's your bench been up to?
Well, a couple of things. Last weekend, I found myself buying a CNC router. It's used, of course, and it's a 3040, which is a little different than the one that you have. You have a 3018, and the 3040 is a robust beast by comparison. Got a really, really hefty mechanism on it, and it's old in that it has a 25-pin serial port going into it. So I hauled all this thing home, and it's a bit of a lug to get it in the basement. And it's not very big. It's, about an 8x16 bed on it, but it's pretty solid steel, so it's heavy. Anyways, of course, first thing you have to do is turn it on. And the minute I turned it on, it started to move, which is interesting because it's not supposed to move if you don't have a computer hooked up to it. So, kind of made Kevin's
switch.
Pardon me?
You didn't pull that fail-safe switch that Kevin was talking
about. Well, it makes Kevin's talk really, really pertinent because this thing's got a mind of its own and it shouldn't have a brain at all. And I'd noticed that the business end of this thing was driving its way towards the bed. So my first thing is to figure out why
Drew,
it's doing anything.
Did it start saying exterminate, exterminate?
I began to wonder. I mean, it was bizarre. So I thought, well, this is very intriguing. Anyway, easy enough to fix. You can change out the board if I have to. I mean, it's not that big a deal. But yeah, that's the thing that's on the bench right now, other than the Ballon that I told you about on Saturday. But
Oh, that reminds me.
Yeah.
Is this your stuff?
Yeah.
I was sitting here thinking, I borrowed this from somebody. Who was it? Okay.
And I am enjoying Dave's rant about the overregulation of drones. I couldn't agree more. But then again,
don't get them going, Drew.
I'm not going to. I'm backing out now. Thank you for your time.
Okay, thanks, Drew, for that. Appreciate it. Do you need anything? You have anything to add to what you've been doing these days, Eric?
Common emitter amplifier. So that's what I'm working on. I just came across the link that you sent me 6 weeks ago for those YouTube videos. So thank you for that.
I'm just about ready to send you more.
So yeah,
you got a nice echo in there. Has Dave got his
Yeah, we got dueling laptops here, but anyway, so
okay,
that's my homework that I'm working on right now is the CEA, and
well, we're going to be most interested in what you bring back from LobsterCon this year.
Yeah. Yep. But that's it for me.
Okay, thanks, Eric. Hassan, have you been doing it, melting any solder of late?
No, nothing radio related yet.
Oh, well, you're going to have to start turning that soldering iron on pretty soon, Hassan.
Yeah, but I do have something to show you, though.
Okay.
Let me turn on the camera.
Nice.
How do I flip the screen around? Okay, I'll just use this. So our project, we were working on a chip. The project was canceled, but we got these as souvenirs. These are the PCBs for it. I don't know if you guys can see this, but look at the dot pitch on this thing. So the pins are spaced so close you cannot even see them with the naked eye. Like, there's 5,000 pins on this. This would have been the biggest chip ever made. This is where the chip goes onto the PCB, and then the other side is just to expand it so the pins come out. But you cannot even see and resolve the individual pins with your eyes. Like, this is the level of manufacturing they're doing now. It's ridiculous.
Well, from this angle, that pitch doesn't look so bad, but 5,000 pins does.
Well, that's because what looks like a solid surface has actually got pins in it as well. I can't turn on my good camera. I don't know if you can see with.
Oh no, everyone's I can see them. Yeah, you can see them.
Mm-hmm. So, yeah, like I think the days of soldering by hand are definitely like you can't even. This is like unbelievable levels of the fine dot pitch between adjacent solder these balls or whatever you call these things.
I'll bring it up to one of Eric's events and we'll solder something to it.
Yeah.
You need to get Cherry to put it under his microscope.
There you go.
Oh yeah, absolutely. I'm gonna have to look at it through whatever I can come up with, magnifying glass. But yeah, so apparently there's so much. When you have 5,000 pins, it requires like, I don't know, 50 kilograms of force just to push this thing in.
Oh,
So
no,
yeah.
No 50 kilograms of force in my shack.
Yeah, that's all.
Okay, thanks, Hassan. Kevin, doing any soldering?
A little bit. I've kind of got an antenna up in the backyard, and it's not an end fed, but it's random length. I'm just trying. I'm a believer that the more wire you have in the air, the better. So I'm just trying to make a balun that gets it down to some reasonable impedance, so that I can match it better. And I've got a couple of different balun. One's purchased, one I built, and it's like they both behave differently. And so yeah, just puttering around with that. But
Well, that could be an interesting talk at some time. What's the difference between the two?
If I ever figure out what's exactly going on and which one is correct or which one is better or whatever, then yeah, that you're right.
Okay.
So it's a process.
Okay, Drew's got a question, I think, for you. Drew?
Oh, okay.
Drew, you have a comment?
Yeah, sorry, I was muted. Yeah, Kevin, one of the things that I'm struggling with these baluns and random wire and end feds is they give you a specific impedance, and I don't know where they get the impedance from for a chunk of wire. And so when they choose 9-to-1 or they choose 49-to-1 or 64-to-1 as the chosen turns ratio or transforming ratio, I'm going to be interested in hearing what you come up with, because I think that they're not correct.
Well, yeah, I sort of agree, but at the same time, it's like, the impedance of a chunk of wire depends on a million things. Well, not a million, a lot of variables, right?
It does.
Height above ground, are there trees nearby? Like in my case, so it's kind of like, I think a best effort kind of basis.
I'm building a 9-to-1 now for a random wire end fed. And the 9-to-1 can also be used for a terminated end fed dipole, which is the one with the 450, 9-to-1 on one end, 450 ohm resistor on the other end.
Yep.
It's going to be interesting to see how close it matches once I set it up.
Yeah, exactly. It's like, anyway, I hear you. It's a process.
It is. Oh yeah, no, and that's why you have a tuner. I know.
Eric, you got a comment?
Yeah, thanks. We were talking about that on the drive today, putting up a random wire or even replacing the balun that's at the end of my end fed. I don't know if that's the problem or not. We did discover some moisture in the matchbox after field day that probably wasn't helping things, but certainly didn't cure the problem by drying it out. But I'm curious, 4-to-1, 9-to-1, what is there not some sort of way of measuring what is necessary? Is there a formula? Are there formulas for this, or is it just trial and error? Like, what's the, what's your magic number? Why is it? Why are those numbers exist? Why isn't it 7-to-1? Why isn't it 16-to-1?
Well, it's because it's harder to wind those cores. That's why, right? Because the impedance ratio goes as the square of the turns. But the other thing is you got to model. I think the best way to do it is to accurately model it, because we don't have the stuff that we need, the many thousands of dollars we'd have to spend on equipment to accurately measure antenna impedance at 3,000 ohms or whatever.
Dave, comment?
Yeah, go back to my presentation I did on my long wire antenna, because I did model it in NEC 4, and I came up with impedances and all that kind of stuff. And I think more so though I was looking at near field, far field radiation patterns, because Kevin was afraid I'd fry my kid if I put my antenna, my long wire and antenna beside my house, that I'd end up frying my kid. But yeah, just a comment about long wires. Yeah, absolutely. The impedance is going to change based on frequency. I have an external auto tuner that my wires connected to, and my ICOM triggers it, and it goes in every time. Like I switch bands, I have to go and tune it to make it come back and match to a 50 ohms. But I think those wires are of the order of several thousand ohms. It's thousands of ohms. Whether it's 3,000 or 6,000 or 5,000, it's going to vary. But that's why with the ICOM tuner, it does that automatically outside. The other thing too is that you got to have a counterpoise. You got to have a good counterpoise connected to your tuner, because these long wires definitely need a counterpoise. And what I did in my backyard, I don't know if you guys remember, I put down chicken wire on my grass, my lawn, and I have my counterpoise is the chicken wire in the grass, and the grass is now overgrown the chicken wire, so you can't even see it in the yard.
Hassan, you got a comment?
Yeah, I think in answer to Eric's question, I always thought that like 9-to-1 basically does the impedance transformation. So if you have 50 ohms coax, after 9-to-1 balun, you've got 450 ohms coming out the other end. And that's how you figure it out. Although I don't know if that's true based on, I think Kevin said that it's a square of the returns ratio. So I don't know. I'm not sure.
Sorry. Yeah. So 9-to-1 is like a 3-to-1 turns ratio, right? But a 9-to-1 takes you from 50 ohm coax to 450 ohm window line.
Yeah, that's right.
So you go from, a balanced window line to an unbalanced coax with a 9-to-1. But if you want to do like exactly. Read that.
Want to borrow it?
Read that.
I've read it backwards and forwards multiple times, every which way. I know, but it's just
You've read this backwards and forwards multiple times. Liar.
no. This is why I crave practical knowledge, because I'm just sick and tired of these research papers and all these articles, optimizing to the nth degree. I want to know what I.
There is a limit to how much your model will show you.
Yes.
I bought a radio frequency current meter.
All right, so you guys, this is summertime. Somebody told us. I think Al told us this is summertime. So get outside and do some practical experimentation with these long wires and report back in the fall.
Here. Well spoken. To the chair.
Okay. Who's up there? Oh, Dwayne moved off. Okay, Howard. Good evening.
All right, can you see me okay?
Yep.
Well, I haven't been doing much because it's summertime, but thanks to Ken, I have some future projects. UBIT version 3 that he didn't want anymore, so that'll be a nice QRP all band radio to play with, and also a QCX on 40, which I'm going to create or change to 20. So I have a couple of the QRP options. And then a friend of mine gave me this to see if I could get it working. And what do you think that is, Peter?
Oh,
Just the way it's going on. So an PA amplifier or something?
No.
Guitar amplifier?
is that a radiola?
No, it's a theremin.
Oh,
I gotta put that with a theremin. Oh my god.
Oh,
I thought you'd like that. I didn't show the. There's the little wands.
oh,
A man after my heart.
Look at Eric.
Oh.
You guys are gonna make an orchestra.
Excuse me, I'm going to have to turn off my camera for a moment here.
So that'll be kind of something to try to get working.
Well, the next time there's something going on at Eric's farm, are you heading down there to join the crowd and bringing it with you?
Because right now there'll be two of them now.
I have a new challenge for everybody. Can you guess what it is? The best theremin.
Ooh.
Challenge
I don't know.
accepted.
I don't know whether, Kevin, I should say, should we bring guitars along, or maybe we should just avoid the theremin weekend?
Instead of the ukulele orchestra, I see a theremin orchestra.
Trend setter, not trend follower.
And Kevin can bring out a kazoo, or I mean, Dave.
I have to pull up weeds in my backyard that weekend. Sorry.
Yeah.
I think the answer to your question about guitars versus theremin is, are we better guitar players than they are theremin players?
Well, I know my amplifier would outblast them, so
As mine would as well. So we could we could at least drown them out if nothing else.
that's right. And you know what? At 3 o'clock in the morning, it'd be music to my ears, anyways. You know, a half a bottle of Jameson's to add into it would certainly help. Okay. Well, that was always my motto for when I was learning guitar. I didn't care how good I got it, just as long as I sounded like in my own mind, I was a rock and roll star at 3 o'clock in the morning after drinking some Jameson's, and I was okay with that. Anyway, okay, I think I've covered off on everybody so far. So anybody else have anything to add before we close off and enjoy what's left of the day?
Very interesting.
Okay, great. All right. Well, thanks everybody for joining tonight. Dave, Eric, hopefully you guys have patched things up and you'll be able to have an enjoyable ride to Maine tomorrow.
We should. It's about 5 hours or so from here, but I'll try to remember to take lots of pictures and have our own spin, our SOAREX spin on the lobster hunt experience.
That sounds like a great idea. Well, enjoy your drive, safe drives tomorrow, and enjoy your weekend, and we'll catch up with you, I guess. Maybe you might stop by again on Tuesday.
Perhaps, yeah.
Or Monday or whatever it is. Okay.
Perfect.
All right, guys, 7-3, and thanks again for joining us, and we'll catch up with you on, what's the date? July 19th.
Thanks,
Ciao.
Peter.
Good night,
Bye, all.
guys. Cheers.
Very good. Good night, guys.
Okay. Good night.
You're still there.
No, I am there. I am here. Yes. Sorry, I muted accidentally there. I need to stop the recording. That was a quick exit for everybody.
Yeah, I think so. You're still recording.
Yeah, I know. I'm just turning it off now.